Start on the phase 2 TCP IP socket programming, where I'll be covering on socket programming, hands-on with client-server programming in Python and Windows and Ubuntu client, and debug tools for socket programming related issues like Wireshark, netstate, ping, ifconfig. So this is like TCP client-server program. If you want to call it a UDP, then yeah, some API need to be changed, like you need to use send to and receive from, like here. But for TCP, you'll be using write and read. So that's what's the only difference. The socket connect remains the same here. So yeah, let me start from the beginning. Yeah, socket programming is required above the TCP UDP layer, and which actually interfaces with the applications. And when you talk about how the today's network models are, it's like client server model, and where when you call it server, what does it mean? Like it is accepting the client connections. And how it is accepting connections? Because it's just getting a socket binding to an IP address called global server IP address, for example, and then it's setting its capability, how many client connections it can accept, and then it puts accept call. And there are many other kind of also accept call like select or poll, which you can use to receive the multiple clients calling the server. So but I will take an example of accept here just for the simplicity. So you can see, like, yeah, in client case also, like you call sockets, you call connect, and connect, you put the IP address of the server, and this way you connect to the server. So all the three-way handshake which I explained in the previous slides, that happens. And then when that happens, then it starts getting, the client starts writing to the server, and its server starts reading and then writing and reading, and when this client is finished, it's called the close, and the end of final reference is read here. Then it's also called a close for the client socket, and it starts serving the end of the clients. So this is the way socket programming works. So socket programming is why is that way, why client server. So you can read this paragraph, which I just thought is my understanding, my thought, that why a client server is required, because given the natural resources, like you have a smartphone, you have the laptops, you have data servers. So like at one end you have like maximum resources, and at the other end you have the less resource. So just to give all of the form factors a level playing field, that they should be usable in all the cases as much as possible. The client-server programming has been developed where servers keeps all the data, all the databases, and gives to the client whenever is requested by the client. And so any socket programming, you understand that is required for applications to use the TCP IP layer and talk to the other end, or maybe a different application on the same host. So this is how the client-server programming is looking like. Is which I think explained again. Web client user process, protocol stack within a kernel, transport layer, network layer, data collecting layer, and this way you have a flow between the client and server. And again, a client server need not to be on the same local area network. So you can see, like, you can be like different hosts. Like I am sitting in my home right now and connected to my server in Intel Technologies in Bellandur office in Bangalore right now, and you can see that like the different routers in between, and they are routing my all the packets, like whatever I'm speaking right now. All that is a kind of a Skype, that's what we use as part of Intel business communication, and that is taking all this graphical data as a TCP IP data. And also I think there are many other group of protocols which may be some based on UDP. They are taking my voice data, what I'm speaking right now, and all my graphical data through different routers, where till IP layer each router is functioning and giving the next destination, like, kind of forwarding the packet, and ultimately my packet is reaching to the server, like maybe server here in internet network, and server maybe some other as defined by the Intel IT network. So that's the way typical clients are programming across internet works. So very interesting concept here is, and anyway, I explained to you about the server socket, like how the server happens. Like you need to create a socket, you need to bind a address to it. Like you have Google server, you have an HTTP server, you need to put a port number, give a server port number, and you need to bind to it. And you will see about port numbers more, like if the same port number can be used for creating different servers. Yes, there are something called socket options that we'll see in the next slides. And then you have listen, which is again saying how much client can accept 5, 10, 15, 20. That's what you are setting out here. And accept is something a blocking call, which actually blocks till a client actually connect to the server, and then accept return a new socket descriptor for that client and pass it to another thread, and that thread then takes care of that client, and accept the original accept starts waiting for the other clients. Okay, and the threads, the client thread actually starts doing the read, write, close operation on the client socket accordingly. And like the same way like socket creating client, you have bind optional connect, write, read, close. That's what you have, what you explained in the my earlier diagram here, what I explained here in earlier diagram. And then you see like once client issues a close, then yeah, the server can also close that socket, the client socket, but it can still be listening for other clients to talk to it. And you can see what I was saying, what UDP again. No, in right case you have send out, send to, and read you have received from for UDP, and same way out here. So you understand that it's really difference in terms of what you're using for reading and writing, except that all is same. Okay, and but same, like there's no listen except in terms of UDP. Okay, sorry, it is say same. No, it's not same. Listen except is not used for UDP servers, and it will be like you do a socket, you bind to an IP address in your port, and this end keeps pumping the packet out here, and this end has to identify okay which UDP port number the packet is being sent to, take identify that and pass the packet to that particular application which has set that port number, like which owns that port number, I mean. Okay, why Shopify designed the way they are? Because yeah, you can understand, because it's sequential in nature. Like you do you create a socket, you connect, you bind to it, you IP address to it, right, on which it should be reachable, and then you call like on one end listen and accept, and on the other end from client you call the connect. So all that is very familiar way of okay, no, I am ready to take your connection, and the client says okay, I am connecting you, and this way the connection happens. And if you understand more that yeah, this like socket descriptor is, yeah, that's what is being returned when a accept call happens, is a told, and that's what is used for further reading writing. And even when whatever the socket create is being called for, when those socket descriptors are used by different applications to talk to the peers. Okay, and closing a socket also is very much required. So please note that when you're getting a socket, when you're getting client socket, you need to close it, otherwise the resources will get exhausted and you will get like no network access. Okay, also like socket option, I was saying like there are different socket options like max segment size, send buffer, receive buffer size, port multiplexing, taking care of network latencies, no, different network behaviors, taking care of flow control like window size, and like how much window size you can keep it, how much not, like what I explained you earlier in this in the phase 1 where I was showing you TCP header. So you have the window size, and that's what is used for flow control. Choices of multiple layer 2 interfaces, like whether if you know now in your mobile phone you have 3G, 4G, you have Bluetooth networking, you have Wi-Fi networking. So which layer to use? That's what you can, like what sockets will you use, what interface, that's what you can use. You can define socket options, and also like be smart clients have some configure time modes, like yeah, when I should send the packet, when I should receive the packet. If this much buffer has been filled up, I will send the packet. If this much has been received, I'll pass to the application. So based on that, you do a very sockets are doing very concise operations, so that the upper layer are independent and independent, and this socket APIs deliver the data reliably to the applications or send the packet reliably across the network. Okay, so this is again about I'm showing you the socket options with you, so you can see that you have socket options called accept connection, return whether it's enabled for listening, and then you have broadcast. So there's few socket options. There are many more, so let's not focus on this much only the many more, but what I want to you have focus on is like linger, which is said about latencies, and what I said about port multiplexing is your reuse addresses bind, and then timeout values and your watermarks and all that. You can report on that. And let's move to next slide. So this is what is how a socket writing to a socket looks like, that you get applications, but like you have data in the application buffer, you start socket descriptor, you connect, and then you start calling write. So socket in buffer makes a TCP packet, like with the MSS size TCP segment, which explain maximum segment size, which is like application data, and it should be less than this 40 byte of IPv4 plus TCP head. TCP is not written, but yeah, 40 byte header of 20 bytes for IPv4 and 20 bytes for TCP header, and 60 bytes for IPv6 in case we are using IPv6. Then less data, then less than like MSS, like yeah, 1460 minus 40, so 1420 bytes what you can send as a like application data, and you can send to that particular MTO supported host. It is 1500 180 bytes. This again the diagram that I covered in phase 1 also. So how the packets are received, like you have DMAC mechanism, like each NIC can transmit a packet to the memory, like to the memory, like wire the memory to the respective socket before the receive queue, and then the applications is like not disturbing the CPU, but using DMA mechanism, and yeah, it's the memory, the RAM gets a packet, and then a hardware interrupt is also raised by the NIC card and giving the address of the memory where the buffer is being copied, and then this buffer is taken back and put in the socket buffer receive queue. Again the same RAM, but at least this fill will be accessed by software interrupt. This kind of a delayed mechanism, and this delayed mechanism will process this packet, look at TCP IP header, and we'll say, okay, this packet is for me because it's my IP address, it's not for others. If it's for others, then I will use forwarding and pass to the my next level gateway, that's what router does. And then after that, after it's get it, it's my own packet, it's my own IP address, it goes to TCP layer, and again looks for the port number, which port number, what software is mapped to that port number, and who has, which application has a socket. So after it comes to socket, it takes put up that in the message buffer and pass to that application. So this way your packets are received and sent. So let me give you the a typical hands-on session right now, and so hands-on session I'll just explain you here is like it is my Linux machine, Ubuntu machine in my lab at Intel, and I'm at home right now, and and this is my server machine, and then I will run a, like I have done socket create, set socket options like the user address, bind, listen, and then I'm creating a using accept and receiving the client connection. And then I'm running this, right? And then I go to the other end and I say, yeah, you is got killed right now, I think somehow, and I will run Python my client, right? You can see it by 8%. There is HTTP 200. Okay, world, right? So sorry. So you can see it here. Is that what I meant? Is like I put HTTP 200. Okay, hello world. Like in the server, I have put this value, right? So this what window is my Windows machine here, right? It is transmitting to Ubuntu machine here. They're saying, oh, I'm a client from this unit. No, sorry, this one. That okay. The client is Ubuntu machine. So this is sending a packet. If you open this API, you can see it is using my server addresses, getting a socket and doing a connect, and then doing a send, and then receiving the data and sending it here. So that's what socket programming is happening right now. And if you see, and in the same way, when my Ubuntu machine is, again this has got expired right now, so you can see again the server, like it has this the IP address of my Ubuntu machine in my Intel lab, and then I am creating a server here. Sorry, there's something happened here. What is that? P my server. So, okay, this is saying there's some problem at line number 10. What I did on line number 10, and okay. I cannot debug right now, and okay, string address already in use. Okay, I did not use the set add. Okay, good example of that. What you got, address already in use. That's what happens when you don't use set socket up with reuse address option. Okay, so if I okay, so let me just due to the time constant, I'll be covering on the slide right now is that what I have been so it's like same lines of programming on both the sides, doesn't matter much. So you can see that no, you do a create socket, set socket options, you do bind, listen, and you do accept, and then yeah, you read the socket, you write the socket, right? Write HTTP response, and then you close the client socket, right? This much option doing, and you learn more in terms of socket programming, and I think in some socket programming internals, which will be covering the more detail onto it. But just the basic socket programming looks like this, like socket create, socket options optional, bind mandatory for server, listen, accept, and then read write. But I explained earlier, and a client looks like that. Okay, I put a server address, I need to connect to the server's address, here is, right, and then write to socket, and then I penetrate, and then I receive the data, and I close the socket. Okay, so that's what it looks like, and that's how the output was looking like when I was doing this program out here. You can see it here right now. And you can notice different source port number from clients. So as I said, source port numbers are not fixed, they can keep changing, and system will decide what port number to be used. Only the destination ports are fixed, like for HTTP is port number 80, FTP is port number 20, DNS is port number 53, SSL is port number 443. So that's why many destination protocols are defined, so servers can listen on the fixed protocols and client from anywhere in the world can talk to that servers on that fixed ports and do a reliable or a useful transaction. Okay, and you can see if I map a simple Wireshark session with the TCP IP header, then how it looks is that you have TCP data till here. Now that you will see it here, and then all this is your TCP header part, which I could not draw a perfect picture out here, but this what you see is like a more readable format is the above box right now, this box, and you can see your source port, destination port, and like for the same session, right, you can see SYNAC and ACK happening, first ACK happening right now, right? First, like for this simple client server programming example, and you can see that you have sequence number out here, always saying sequence number 0 packet, and like for send, right, it's 0th number sequenced, and then +1 is, it keeps on doing how many bytes extra getting to that send packet. So if you can see, the length is 74 bytes. Okay, so like TCP length is 74 bytes, which means it is including the IP header field and not the Ethernet header. Okay, and then you can see acknowledgement number. You can see the acknowledgement number here, which is again the first packet, so no acknowledgement, and then you can see this bit flag marked as send, right, and then you see window size value, which is again a 29K. Okay, so this packet you can send, and then it will not look for an ACK, but after this it will look for an ACK. So the line can receive this much bytes, like this many before it has, then it will keep sending the ACK once it keeps receiving this packet, and then this value will get updated again in the receiving packet. Now again you will see the window size. So this the sender end will keep making note how much window size is remaining, and that much byte I will keep sending at a faster speed. So there's a way the flow control is also happening over the network. So please remember this keyword, flow control, very important in today's world of different networks, different form factors, and billions of form factors. So a lot of communications, a lot of networks, unpredictable behavior, and a lot of network congestions happening, and this flow control is very important keyword, very important concept to be understood, which is taken care by the TCP. Okay, and then we go to the next slide. So again, so what I was saying is that is socket tools can state NI used for the socket for a particular interface, networks, net segments, and also the routing table. Okay, and ping you can use just to check the reachability of the other end, ping 6, if config just to see what address you got by DHCPv6 or DHCPv4, and TCP dump is just to capture the packet and ensure the Wireshark. So with this, the socket programming is also complete. Thank you very much.